Good afternoon, ladies and gentlemen. We're back once again with another video. And our video today is going to be on covalent bonds. So let's go ahead and get started. First question we want to ask ourselves is, why do atoms form bonds? And our answer is quite simple. Atoms form bonds in order to become stable, which means they want a full outer ring or shell of electrons. So let's explain that more in detail by going through the following topic. So Lewis dot structures. What are Lewis dot structures? They're actually quite simple as well. They're element symbols with the number of valence electrons displayed around them. So I give an example. So let's look at hydrogen. Hydrogen has one valence electron, so I draw the symbol for hydrogen, which is H, and then I put that one valence electron, and there we're done. Let's take a look at another one. Let's look at chlorine. Chlorine, the symbol for chlorine is Cl, and then chlorine has 7 valence electrons. And so what I do is I go ahead and put that symbol like we just did, and then I just draw those 7 valence electrons. And what we've just shown is that hydrogen has 1 valence electron, chlorine has 7 valence electrons, and we did that without making the very large and cumbersome Bohr model. So let's move on to our next concept. So using our Lewis dot structure, we're going to be looking at covalent bonds. And what are they? Covalent bonds are a bond in which 2 or more nonmetals share valence electrons in order to be stable. So let's take a look at this. We have our world famous example of covalent bonds when we talk about water. So water has, and each hydrogen in water has 1 valence electron, and the oxygen has 6 valence electrons. And since these are non-metals, they're going to share these valence electrons. And how do we show them sharing? Well, we just draw a line going from each one. So I drew a line going from hydrogen to oxygen, and then, I drew a line, and now I draw a line going from this oxygen to this hydrogen. Now, how does this work? Each hydrogen wants to have 2 valence electrons, and if you look at it, this hydrogen has 2 valence electrons, and so does this hydrogen as well. And then if you look at oxygen, oxygen wants to have 8 valence electrons. Well, by sharing these electrons with hydrogen, oxygen now has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So all 3 are happy and stable in this bond. So let's look at our next one. So now let's look at methane, also known as CH4. There's a chemical formula for it, but I'll write it out. So we're looking at methane. Once again, hydrogen has 1 valence electron. How do I know? Because you can always refer back to your periodic table where that information is displayed. And then carbon has 4 valence electrons. So we'll draw it up here nice and neat. And just like we did in the last one, we're just going to draw a line going from each, which is showing that they're forming covalent bonds by sharing these electrons. So carbon is a nonmetal, these hydrogens are nonmetals, so that further lets us know that this is a covalent bond because there's 2 or more nonmetals sharing valence electrons. Each hydrogen has 2 valence electrons, and carbon has 8 valence electrons. So they are all happy and stable. Let's take a look at our next one. So now let's take a look at O2, and we're going to set it up. And if you notice, each oxygen has 6 valence electrons, and these are 2 nonmetals, so it's going to be a covalent bond, so they're going to be sharing electrons. So now look, if you look in oxygens, if you look at both these oxygens, they are sharing these 2 valence electrons in the middle. And since these are 2 bonds, this is actually called a double covalent bond right here in the middle. Why is it double? Because we have 2 bonds in the middle being shared. So now let's go ahead and take a look at our next one. Now it says define covalent bond. Remember, covalent bond is when 2 or more nonmetals share valence electrons in order to be stable. So we have a chart below, and we're just going to go ahead and fill out our chart using our periodic table. So carbon, looking at your periodic table, has 4 protons. It has 4 electrons because in an electrically neutral atom, the protons and electrons are the same. And then it has 4 valence electrons,
And how many valence electrons are needed to fill the outer electron level? Well, it needs 4 more. Why? Because 4 valence electrons plus 4 more needed gives us 8. So now let's look at chlorine. Chlorine has 17 protons, 17 electrons. It has 7 valence electrons, and it needs 1 more valence electron in order to be stable. Hydrogen, 1 proton, 1 electron, 1 valence electron, and hydrogen only needs 1 more to be stable. If you notice, hydrogen has an asterisk around it, and what does that mean? That means it's an exception to the octet rule, because in its first ring, hydrogen only needs 2 valence electrons. It doesn't need 8, so it's an exception to the octet rule. And so now let's go down here with oxygen. Oxygen has 8 protons, 8 electrons, and then it has 6 valence electrons. So how many more does it need? Well, 6 plus 2 gives us 8 valence electrons for oxygen. So let's continue on to the next one. So now you're going to take 30 seconds apiece to actually make a covalent bond for problems number 1, 2, and 3. And I'll start you on problem number 1, and I'll give you 30 seconds to make the covalent bond for it, and I'll stop the video starting now. Alright, we're back. And so now, if you did yours properly, you showed that each hydrogen had 1 valence electron, and they connected right there, showing that covalent bond by them sharing those valence electrons. Now, I'm going to give you 30 seconds for chlorine, and I'll stop the video now. Alright, we're back. And if you did yours correctly, you showed that each chlorine has 7 valence electrons. And then what do? We share those in the middle, forming that covalent bond. And last but not least, let's go ahead and look at CO2, carbon dioxide, and it's written or shown as OCO. So we're going to take 30 seconds to fill this one out, and I'll stop the video now. Alright, ladies and gentlemen, we're back. So if you did yours correctly, and you want 6 valence electrons for each oxygen, and then 4 valence electrons for carbon, and I just make the connection: CO2, CO2. So now if we look at it, oxygen has 8 valence electrons, carbon has 8 valence electrons, and then this oxygen has 8 valence electrons. Ladies and gentlemen, I hope this tutorial was helpful. I'm Chivy Spivey signing off with my son Jordan Spivey signing off. Take care. Y'all have an awesome day. Peace.